Hi, everybody. Today we are verifying trig identities. We learned about some identities in the last lesson. You can check that out. Today we're going to learn about the Pythagorean identities. Those identities are down here. They're written out for you. First, we're going to talk about how they came to be. If you think about Pythagorean theorem, a squared plus b squared equals c squared. This is our new version of it. X squared plus y squared equals r squared. Right? We're going to manipulate this by dividing by r squared, dividing everything by r squared. If you think about what would happen here, r squared divided by r squared is 1. And then think about what is here. So x over r we know is cosine, and we know it's squared here, right? And then we have plus our y squared over r. Y over r would be sine, and in this case, it's squared. So we're really saying like cosine squared theta plus sine squared theta would be equal to 1. We can also move these around, right? So we could, like sine squared can go first and cosine can go second. We can also go ahead and subtract sine squared x on both sides. So you could say, okay, cosine squared x is equal to 1 minus sine squared x, like that. Or you could say the same is true if we move cosine x to the other side, right? So if we subtract cosine squared x, then we would end up with sine squared x is equal to 1 minus cosine squared, right? So any of those things can be recognized as equal to each other. So that's what happens if we divide r squared on both sides. If we divide x squared on both sides, this is going to cancel, give us 1 plus y over x is tangent squared. I'm going to use theta here. And then r over x, remember, is secant. It's the opposite of cosine, secant squared, right? So we could move tangent over here. We could say 1 is equal to secant squared x minus tangent squared x, or theta. Sorry, I guess we're using theta here. So you can move them around if necessary, but you can be thinking, okay, if I have tangent and secant and 1, then I know I have an identity. If I have cosine, sine, and 1, I know I have an identity. So finally, this one is what happens if you divide by y squared. Right, so x over y, remember, is cotangent squared x plus 1 would be equal to an r over y, opposite of sine, cosecant squared x. Right, so remember, you can move these around as well. So these are the major ones to remember and recognize. I would say the most important one is that first one, sine cosine equaling 1. That comes up the most often. So if there's one that you're going to commit to memory, I would definitely do this one here. Okay. So today we are verifying trig identities. So to verify means to check if something is true. So for example, in our first example, it says tangent theta times cotangent theta equals 1. Right? That is what we are going to discover if that is true. We want to verify. We want to say, yes, this is true. So the basic strategy is this. Simplify the more complicated side to see if it's the same as the other. So in this case, tangent times cotangent is more complicated than 1. So we're going to try to simplify that side. In this case, you can decide on each of these which one you want to simplify. You can also simplify both. So like that's also possible. But you want to, the basic strategy is to start with the more complicated one that looks more complicated. So let's start with this one here. So tangent, as you remember last time, wait for this lag, is sine over cosine being multiplied times cotangent, which is cosine over sine. So you could say, okay, sine divided by sine is going to be 1. Cosine divided by cosine is going to be 1. So 1 equals 1. We check that they are in fact true. This is how we would verify that something is equal to each other. So we're verifying that it's an identity. Right, it is. So we could say, okay, this is correct. All right. Let's try B here. So I see 1 minus sine squared theta. So I'm going to go ahead and look at my Pythagorean triple or Pythagorean theorem identities and see, I can see 1 minus sine squared. So if I'm thinking here, okay, I'm going to move sine squared over, right? It's going to cancel here and leave me with cosine equals 1 minus sine squared, right? That's what I have here. So I say, okay, so this right here, oops, so sorry. This right here, that top, the numerator, can change into cosine squared theta over cosine theta, right? That green part translating into this version here. I need it to be equal to cosine theta. So I'm going to go ahead and simplify this side here. So I'd have cosine theta times cosine over cosine. Cancel, cancel, leaves me with just cosine theta equals cosine theta, right? They are equal to each other. That means that this is correct. All right, so notice we're just translating. We're continuing to use the same ideas of identities, exchanging one thing for its equivalent. All right, let's look at this one. All right, so I have tangent theta. I could change that into sine over cosine, right? I have 1 minus sine squared. I think we just did that here, so I know 1 minus sine squared is the same as cosine squared. So I'm turning this into cosine squared theta. So I'm turning this into this here. It needs to be equal to this. So I'm going to try not to touch that side, the less complicated side. I'm not going to touch it unless I have to. So here I would have sine theta over cosine theta times cosine theta cosine theta. I'm going to go ahead and cancel. Cancel. That's going to leave me with sine theta times cosine theta be equal to sine times cosine. So they are equivalent to each other, right? This is what we call verified. All right, so far we've just exchanged things until they equal what's on the side here. So you can see you should always have one side, hopefully, will stay the same throughout until you've turned the left side or the right side of the other side into that same thing. So let's take a look at this one here. So cosine squared theta over 1 minus sine theta. Notice I would be tempted to change it into 1 minus sine squared, but it's not squared, so I cannot change it here, right? Cosine squared theta, I could change that into like 1 minus sine squared theta. And you might be tempted to like cross these out, but we can't because there's subtraction there. So there's nothing I can do here, right? One thing that I could do is get rid of the fraction. So I'm going to go ahead and do 1 minus sine theta on both sides. So that's going to mean that this will cancel here and leave me with just cosine squared theta equals, I'm going to go ahead and like distribute, double distribute or box this. I mean, you could literally do this in the box if you wanted. Kind of a complicated box situation. 1 minus sine theta. So 1 times 1 would be 1. Sine theta times 1 would be sine theta. 1 times negative sine theta, negative sine theta. These are going to cancel each other out. Negative sine times positive sine would be negative sine squared. All right, so we have 1 minus sine squared theta. 1 minus sine squared theta. Right. Kind of wild, but this part here is coming to be here. That's what happens when you take this and put it into the box. Right. So now I know 1 minus sine squared theta. That was one of my original my original ones that I was talking about here, is equal to cosine squared theta. So I'd have cosine squared theta equals cosine squared theta. I see that those are true. This is not the only way to do this problem. With lots of these problems, there are different ways you can go. I'm just showing you one potential direction. All right, last one. This is our most challenging one today. All right, so this is the easier side. I'm going to try to leave that as much as I can. This is my harder side. Start here with sine theta times tangent. I'm going to turn into sine theta over cosine theta. So I have cosine theta plus sine squared theta over cosine theta. I can't add these together right now because they don't have the same denominator. Right? I can make them have the same denominator if I did cosine theta on top and on bottom. Right? So now on top here, it's going to be cosine squared over cosine. This one's coming straight down. Sine squared theta over cosine theta. Say, okay, now they have the same denominator, so I can write it as one fraction. And I can have cosine squared theta plus sine squared theta. And that's going to give me cosine squared plus sine squared. I remember is that this one, sine squared plus cosine. They're just flipped, and that's okay. So I have sine plus cosine equals 1. So all of this can just be replaced with the number 1. Still have cosine theta on the bottom, and it should be equal to secant theta coming straight down. And we know that 1 over cosine is secant theta. Yay. So we have verified that they are correct. So when you are verifying, right, you can exchange just like we were using our identities last time. But when we're verifying, the answer is just like the left side equals the right side. We're trying to prove that they are the same. All right. So that is our notes for today. As you notice, we didn't even use these other ones. They do exist, but they're much less common, right? We're much more likely to use sine and cosine throughout our problems. Okay. For your assignment today, you have your notes here. You're going to choose 8 questions out of 1 through 10. So in these first 2, notice there's no equal sign. The direction just says simplify. So you're going to just exchange out until you get one of these answers. Then for 5 through 10, you're verifying that each is an identity. So doing what we were doing just now in the notes, you're trying to make it equal the lower key side. If you want to try to write your own, you can here. It could be a cool task. You'll notice there aren't any answers because the answer's already in the problem. Right? Finally, you have 4 more questions for review, similar to assignment 33. Go ahead and go back and check those. You have your answers here. You have some optional ACT practice if you'd like. You can check those out and get some extra credit. Thanks, y'all. Have a good one.